Okay, this is the review for Unit 6. Question 1 and Question 2 are from 8.1. Question 1 is finding the first four terms given an nth term formula. Question 2 is finding the first four terms using a recursive formula. So for question 1, if I want to find the first term, I plug in n equals 1. So that's going to give me a 3 in the numerator and a 2 in the denominator. To find the second term, I plug in n equals 2. That's going to give me a 5 in the numerator and then 2 squared in the denominator. For the third term, I plug n equals 3. That's going to give me a 7 in the numerator. And then 2 to the third power is 8. And then for the fourth term, plug in a 4 for n, so that's going to give me a 9. And then in the denominator is 2 to the fourth power, which is 16. Now for question 2, a recursive formula, it states here that the first term is 8. And then it says to get the next term, you take the previous term, that's what a sub n minus 1 means, previous term, and you add 10. So to find this term, I take the previous term and add 10. So that's going to be 18, and then you just keep adding 10 to the previous term. Question 3 is from 8.2. We have to determine if the series is arithmetic. If it is, find the common difference in the nth term. So looking from 6 to 16 to 26 to 36, looks like we're adding 10 every time. So it is arithmetic. Common difference is adding 10 every time. And then the nth term is going to be 10n. And if we consider if there was a term, a zero term in front of the first term, that zero term would be -6. So it's actually, sorry, it'd be -4. -4 plus 10 would be 6. So 10n minus 4. The other way to do this is to use the formula from 8.1 for the nth term of an arithmetic sequence. It was first term plus n minus 1 times d, so that would be 6 plus n minus 1 times 10. And if you simplify that, you'd get 10n minus 4. So the nth term is 10n minus 4. Now, question 4, if we go from -15 to -5 to 5 to 15, we have to determine if we've got a common difference. If so, then it's arithmetic. Now, it looks like to go from -15 to -5, we add 10. -5 to 5, we add 10. 5 to 15. So it is arithmetic. We have the same common difference. Common difference is 10, which means the nth term is going to be 10n. And if we considered a zero term in front of the first term, it would be -25. You could also use the same formula as the last question. A sub n equals first term plus n minus 1 times d. Question 5 is also from 8.2. It's the partial sum of an arithmetic sequence. The formula for the partial sum is n over 2. N stands for the number of terms you're adding together, so n over 2, and then first term plus last term. So the sum of the first 15 terms is going to be 15 divided by 2, and then we need to figure out the first term and the last term. And to figure that out, we're going to use this nth term formula. Plug in n equals 1, you're going to get 10 minus 2, which is 8. If you plug in n equals 15, you're going to get 150 minus 2, which is 148. So we have 15 halves multiplied by 156. So 1,170. For question 6, we're finding the sum again. So we're going to use this formula. We know the first term and we know the last term. The problem is I don't know how many terms that is. So what I'm going to do is find the nth term formula, and it looks like we're adding 5 every time. And if there were a term here in front of that 0 term, it would be 5. Now I know the last term here is 80. So I can solve this equation to find n. Remember, n means the number of terms. If I subtract 5, I get 75. And then 75 divided by 5 is 15. So we're adding 15 terms together again. So the sum of these first 15 terms is 15 over 2. And then the first term plus the last term. So this is 15 over 2 times 90. So that's 675. Okay, question 7 is from 8.3, where we started talking about geometric sequences. So to find the first 5 terms and the common ratio. Well, the nth term formula for a geometric sequence is exponential in form, and the base of the exponential is the common ratio. So here the common ratio is 3, and in this formula a sub 1 is that coefficient there, so the first term is 4. You can also figure that out if you plug n equals 1. 1 minus 1 is 0, 3 to the first power, or 3 to the 0 power is 1, and 1 times 4 is 4. So the first term is 4, and then according to this, common ratio is 3, so we just multiply by 3 every time, so the next term is 12, next term is 36, 36 times 3, I believe that's 108, but I better check, 36 times 3, it's 108, and then 324, so we have 108, 324 for the first 5 terms. Question 8, similar thing, common ratio is 1/3, and then the first term here is that 3 over 2, so 3 over 2, and if we multiply that by 1/3, we're going to get 1 over 6. If we multiply that by 1/3, sorry, let's try that again. Multiply that by 1/3, we're going to get 3 over 6, and that's 1/2. If we multiply that by 1/3, we get 1/6. If we multiply that by 1/3, we get 1/18. And if we multiply that by 1/3, let's see, 18 times 3, that's 30, 50, I think it's 54, 1 over 54. Better verify that. $54. Okay, question 9. We need to find the common ratio in the nth term given that these are geometric sequences. So we need to figure out from 2 to 10, looks like we're multiplying by 5, 10 to 50 multiplying by 5. So the common ratio is 5. The nth term of a geometric sequence is first term times common ratio to the n minus 1. So the first term is 2, common ratio is 5 to the n minus 1. For question 10, from -3 to -3/2, it looks like we multiply by 1/2. From -3/2 to -3/4, looks like it's 1/2 again. So the common ratio is 1/2, and then the nth term then is going to be first term times common ratio to n minus 1. Okay, question 11. We need to find a specific term. Well, it says, let's see, given these two terms, find the common ratio in the nth term. So we're just finding an nth term again. But we haven't been given the sequence in order. We've been given a third term and a sixth term. So if we have first term, second term, and then the third term is 50, and then we have a fourth term, a fifth term, and then the sixth term is 6,250. To go from the third term to the fourth term, I would multiply by a common ratio. And then to go from the fourth term to the fifth term, I'd multiply by another common ratio. And then to go from the fifth term to the sixth term, I'd multiply by another common ratio. So if I take 50 and multiply it by r, and by r again, so that's multiplied by r cubed, that's going to give me 6,250. So solving this equation, I can find r. So if I divide 6,250 by, what was it, 50? I get 125. So r cubed is 125. If I do the cube root of 125, I get r equals 5. Now, knowing the common ratio is only half of what I need to find the nth term. I need to know the first term. So first term, if I take the third term and divide it by 5, I'm going to get 10. And if I take that and divide it by 5, I get 2. So it looks like the first term is 2, and coincidentally, I guess that's just the same sequence, geometric sequence as from question 9, oddly enough. So the common, or the nth term there would be first term times the ratio to the power of n minus 1. Okay, question 12 is evaluating an infinite geometric series. The formula for the sum of an infinite geometric series is first term over 1 minus r, but you have to remember that's only if the absolute value of r is less than or equal to 1. If we check the formula there, r is 0.2, so that's less than 1. So since we have a common ratio here that's less than 1, we can use this infinite sum formula. So we need the first term. There's the first term, or you could plug in k equals 1. Now, it's okay here to have a variable other than n as long as this variable matches that variable. Just wanted to clarify there. But the first term you could find by plugging in k equals 1. 1 minus 1 is 0, 0.2 to the 0 power is 1, and then 1 times 3 is 3. So the first term is 3, and then 1 minus 0.2. So this is 3 divided by 0.8. So 3 divided by 0.8 is 3.75. Now, for question 13, we have an infinite series, indicated here by the dot, 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 but what we don't know is, like over here, what's this common ratio? To go from 64 to 16, and then 16 to 4, and then 4 to 1, it looks like the common ratio is 1/4, and the first term is a sub 1. So since the common ratio is less than 1, we can use the same formula, first term over 1 minus r. So this is 64 divided by 1 minus 1/4 is 3/4. So 64 divided by 3/4 is 85.33333. Now, for question 14, I'm going to expand this binomial using Pascal's triangle. So I'm going to write this over here just as a reference. And since we're raising this to the 4th power, I need row 4. And if you remember, the top row is actually row 0. This is row 1, this is row 2, this is row 3. So I need one more row to get row 4. So there's my coefficients. And what I suggested in class is you expand the binomial just using a and b as a template. So the first one is going to be 1, because that's my coefficient, and then a to the 4th. And then the next coefficient is 4, and then it's going to be a cubed, b to the 1st. And then the next coefficient is 6, and then it's going to be a squared, b squared. The next coefficient is 4, and that's going to be a to the 1st, b cubed. And then the last coefficient is 1, and it's going to be b to the 4th. So there's your template into which you can plug a is 3y and b is 1. So this is going to be 3y to the 4th plus 4 times 3y cubed times 1 plus 6 times 3y squared times 1 squared plus 4 times 3y times 1 cubed plus 1 the 4th power. 3y raised to the 4th power is 81 y to the 4th. And then here you do this exponent first. 3y cubed is 27, or 3y to the 3rd power is 27y cubed. And then you add 27 times 4. It's 108. So we have 108 y cubed. Here we have 3y to the 2nd power, that's 9y squared. 9y squared times 1 is still 9y squared. And 9y squared times 6 is 54y squared. Then here we're going to have 3y times 4 times 1, so that's 12y. And then plus 1. Okay, so this one is a little more specific. We just need the 3rd term of this expansion. And we're raising it to the 3rd power, so we're going to need row 3. And the 3rd term in row 3 is going to have a coefficient of 3. And then if we think about the expansion of this, it's going to be b cubed plus 3, and then b squared times a plus 3 times b. Actually, let me back up here. B squared times 2a, and then 3 times b times 2a squared plus 1 times 2a cubed. Now the third term is going to be this one, so it's 3 times b times 2a squared. This is 3 times b times 4a squared, which is 12 times b times a squared.